Hello, hello, good evening, Subhana, good evening. I hope the voice and the video is clear. I hope the voice and the video is clear. Still anyone is in the live? Still anyone is in the live? Good evening, Nitya, good evening. Right. Good evening, Joshita, good evening. Now we will start the lecture. In the last class, we have studied about the how to identify mole concept or how to identify the mole, and when they have given the, if they are asking the molecule, how to identify the molecule. If they are asking the atoms, how to identify the atoms. Then now from the, if suppose if they have given the weight and if they are asking the volume, how to convert, interconvert, that all we have studied in the last class, and we have did the questions also. Now once again I will recap the this concept once. Now actually my dear friends, due to some the network issue, I was stopping my camera. Okay, once the, if the, once if that current or this current comes, I will turn on my camera. Now you see here, once again I will recap very fastly. Here if suppose number of moles, the number of moles 3 we are having, right? Weight of the substance, volume of the gas at STP, and the number of particles. Now if suppose if they are asking about the volume of the gas and weight of the substance given, from weight of the substance you first find the number of moles. From there, if you multiply 22.4 liter of the, which one, 22.4 liter, then you will get the volume of the gas. So according to the given questions, we have to interconvert this formula, right? Then after that, the next one, what we are having, the next formula we are having number of atom, 1 gram atom or 1 gram molecule. If you see, 1 gram atom will be equal to 1 mole. Now 1 gram molecule will be 1 mole. Then number of atoms is equal to, good evening Jasmine, good evening. Next one we are having number of atoms formula. Now what is the number of atoms formula? N into Avogadro number into atomicity, right? Number of molecules formula, N into Avogadro number, right? Now these are the formulas. Based on these formulas we have did the n number of questions. Now today we are going to deal now very interesting concept, and based on this concept we are having the n number of questions, right? Now what is the concept that we are going to study? Now before going to start this concept, I want to discuss one important and very interesting concept. Actually this concept we are going to study in the states of matter, but based on that concept, here in the mole concept they are asking the questions, right? So that first one we are going to see about the ideal gas equation, right? Now what is the meaning of the ideal gas equation? How this ideal gas equation it has came in the states of matter, I will explain very clearly. But as of now you just remember, ideal gas equation means PV is equal to nRT. PV is equal to nRT. Here the P is equal to pressure, right? V is equal to volume, right? N is equal to number of moles. N is equal to number of moles. R is the universal gas constant. This will play very crucial role. This is a universal gas constant. And T is the temperature, right? T is the temperature. Now here this is the one ideal gas equation. See, sir, I will give you one brief introduction. What is the meaning of the ideal gas equation? Why we are going to use this ideal gas equation? Actually, now any gas to behave as an ideal gas, any gas to behave, ideal gas. Actually, there is no any perfect ideal gas in our universe. Now, any gas to behave the ideal gas, the first condition it should have no attraction between gas molecules. There is no any attraction between the gas molecules. That is the first key point. Means here when there is no any attraction between the gas molecules, that type of the that type of the gases we call it as a ideal gas. No attraction between the gaseous molecule, that we call it as a ideal gas. Second one, what volume of the ideal gas? Better no need of this point, better you remember this point. There is no any attraction between the gaseous molecule, right? Now there is no any perfect ideal gas in our universe. Why? Because even though the non-polar gases, for a few seconds they are attracting and they are forming the bond called van der Waals bond. We know van der Waals bond means for a few seconds, even though those are the non-polar, for a few seconds they are attracting and they are forming the van der Waals bond. Means any gas to be behave as the ideal gas, there is no any attraction between the gaseous molecule, right? When there is no any attraction force, means then only it will behave as the ideal. But even though the non-polar gases for a few seconds they are attracting, means whatever the gases we are having in our universe, all are real gases. So that real gases, when it will behave as the ideal gas, this is real gas. So this real gas, when it will be behave as the ideal gas, can anyone say me the condition? Can anyone say me when the real gas will be act as the ideal gas? If you know the condition, I mean like I will write high temperature, high pressure, this is A. Now B, high temp, low pressure. C, low temperature, low pressure. Clear? Out of these three conditions, in which condition real gas will be behave as ideal gas? In which condition this real gas will be behave as ideal gas? Can anyone? If you know the answer, say me. If you don't know, give me the question mark. I will explain. If you don't know the answer, give me the question mark. I'm ready to explain. My dear friends, if you don't know, give me the question mark. See, ma'am, what it should be that these two are the real gases, right? Now listen. These are the real gases, right? These two are the real gases. First of all, any gas to behave as an ideal gas, no attraction between them. Means if these two are the gas molecules, good evening, Amma, good evening. Now, if these two are the gas molecules, these are the one non-polar gases and this is the one non-polar gas, right? Here for a few seconds they are attracting. Due to that attraction, here the bond forming it is a van der Waals bond, right? If I increase the temperature, these two gas molecules will move far away from them, right? If I increase the temperature, these two gas molecules will move far away from them, right? Now, if I increase the high pressure, if I kept, what happened? These gas molecules will come closer. If I increase the temperature, you know, right? Example, vacuum pump. If you increase the high temperature, all the dust will comes to the one place, right? In the same way, if I increase the high pressure, what happened? Again, this gas molecule will comes closer and they will attract. So if they are attracting, they are behaving as a real gas. Then if I maintain the low pressure, then what it will happen? These two gas molecules will not come closer. They will be far away from them. If they are far away from them, there is no any attraction between them. When there is no any attraction between them, then the real gases will also behave as the ideal gas. So the condition should be high temperature and low pressure it should be there. High temperature and the low pressure it should be there. Any gas to be behave as a ideal gas. Right? I hope it is clear for you. I hope it is clear for you. This is about the ideal gas. Actually, this is about the ideal gas, and any gas to behave as the ideal gas, that it should be satisfy this formula. If any gas is behaving as the ideal gas, that gas will satisfy this formula. Right? I hope it is clear for you how the ideal gas it has came. Ideal gas is equal to PV is equal to nRT. PV is equal to nRT. Right, done. Now next units we'll see. Some units which we are going to use. Some units which we are going to use in our what? In our mole concept. These units will play a very important role, and these units are helpful for us for the fast calculation purpose. For the fast calculation purpose, these units will play very units. Now in these units, just I want to explain you, or once again I want to give you the one easy statement how to identify the any units. See, in the units, first thing, if you are going from the small unit to the bigger unit, smaller unit to the bigger unit. Now if you are going from smaller unit to the bigger unit, power will varies in the negative, 10 to the power negative. If you are coming from the bigger unit to the smaller unit, power will be varies in the 10 to the power positive. Right? 10 to the power positive. Example, we know 1 kg is equal to 10 to the power 3 grams. 10 to the power 3 grams. We know kg is the bigger unit. From the bigger unit, if you are going to the smaller unit, power will be varies in the positive, right? So 10 to the power plus 3. Now 1 gram is equal to 10 to the power minus 3 kg, right? Now gram is the smaller unit, and if you are going from the smaller unit to the higher unit, now power will be varies in the 10 to the power minus 3. 10 to the power minus 3. 10 to the power minus 3 means it is 10 to the power negative. If you remember this one, now whatever may be the question they may ask, you will never and ever you will get, or you will never and ever you will do the mistake. Never and ever you will do the mistake. I hope it is clear. Right? Now we'll see the unit conversions one by one, or units of the ideal gas. First unit we are going to see, that is about the pressure. First unit we are going to see about the pressure. Now the pressure unit here, the pressure unit that we are going to see, that is 1 atm. Pressure unit that repeatedly we are going to use, that is 1 atm. 1 atm is equal to 1.013 into 10 to the power 5 Pascal. Right? Now this 1 atm, again this 1 atm we are going to see 1.013 bar. Right? Next 1 atm, this 1 atm is equal to 760 mm of Hg. Right? This is also one unit we can use. Now 1 atm is equal to 760 centimeter of Hg. This is also we can use. Clear? Now these are the some pressure units we are having. These are the some pressure units that we are going to use. Right? Clear? Now here the one, we can use the Pascal also. 1 Pascal is equal to Newton per meter square, or dyne per centimeter square. Clear? Now these are the some pressure units that we are going to use. Next one. This is volume. This volume units will play a very crucial role in our mole concept. Clear? Now what are the volume units that we are having? Now what are we are going to use? Now, second one, volume units. In this volume unit, we know here the volume units what we are going to see, ml and the liter. ml and the liter we are going to use, right? Here which is a bigger unit, ml or liter? ml or the liter? Liter is a bigger unit. From the liter again we are having the 1 meter cube, right? Now if you go from the ml to liter, power will be varies in the 10 to the power minus 3. 10 to the power minus 3. And if you go from the liter to the meter cube, it will be varies in the 10 to the power minus 3. And if you come from the meter cube to the liter, it will be the 10 to the power plus 3. Liter to the ml, it will be the 10 to the power plus 3. Means 1 liter is equal to 10 to the power plus 3 ml. 1 liter is equal to 10 to the power plus 3 ml, right? Right? I hope it is clear for everyone. Now, this 1 liter only we can say it as a 10 to the power 3 cc. This 1 ml only, 1 liter only we can say it as a 10 to the power 3 centimeter cube. 10 to the power 3 centimeter cube. Same, this 1 liter will be equal to the 1 decimeter cube. 1 liter is equal to 1 decimeter cube also. Sir, how come this 1 liter is equal to 1 decimeter cube? Now I will prove it. Now you see. Here 1 liter is equal to 10 to the power 3 centimeter cube, right? Centimeter cube. So 1 meter is equal to 10 to the power 2 centimeter cube. Sorry, 1 meter is equal to 10 to the power 2 centimeter. Then this meter is a smaller. This is a bigger and this is a smaller unit, right? Now 1 centimeter is equal to 10 to the power minus 2 meter. Now from the bigger unit to if you are going to the smaller unit, power will be varies in the positive. From the smaller unit to the bigger unit if you are going, the power will be varies in the 10 to the power negative. I hope it is clear for everyone. Now this is a 1 centimeter is equal to 10 to the power minus 2. Then this 1 centimeter cube here he is asking, right? Just you substitute here 10 to the power 3. Now 10 to the power minus 2 meter whole cube. Then this one will become 10 to the power 3 and 10 to the power minus 6 meter cube. 10 to the power minus 3 and 10 to the power minus 2. Now this it will become 10 to the power minus 3 meter cube. 10 to the power minus 3 meter cube. Clear? Here the common what it is there? 10 to the power minus 1, 10 to the power minus 1 meter whole cube. 10 to the power minus 1 meter whole cube. Now 10 to the power 1, 10 to the power minus 1 we can write it as a which one? 1 by 10, right? 1 by 10 is nothing but deci. This is nothing but deci. 1 by 10 is nothing but deci only, right? That we call it as a 1 decimeter cube. So 1 liter is equal to 1 decimeter cube. Clear? I hope it is clear for everyone. 1 liter is equal to 1 decimeter cube. In this manner 1 liter, if suppose in the question 1 liter if they have given, 1 decimeter cube if they have given, to make you confused they will give you the 1 decimeter cube. If they have given the 1 decimeter cube also, you should not get confused that it is nothing but 1 liter only. 1 decimeter cube of the gas occupied something if they have given means you should not get confused. So 1 liter is equal to 1 decimeter cube only. Here I was proved, right? Means 1 liter we can write it as 1 liter is equal to 1 decimeter cube. 1 decimeter cube will be equal to 1000 ml, will be equal to 1000 centimeter cube, will be equal to 1000 cc, right? I hope it is clear for everyone. I hope it is clear for everyone. Done? Clear? Now this is about the which one? This is about the volume units. Now if suppose temperature they have given, my dear friends, once again I was saying you, if suppose the temperature they have given in the question, blindly you just convert that into the Kelvin scale. Sir, how to convert the Kelvin scale? Now Kelvin scale, temperature in the Kelvin is equal to temperature in the degrees Celsius plus you add the 273, right? If suppose Kelvin they have given, and if they are asking in the degrees Celsius, just one thing what you do, temperature in the degrees Celsius will be equal to, now temperature in the Kelvin minus 273, if you do, you will get the temperature in the degree scale. Temperature in the Kelvin scale and the temperature in the degree scale, we got it, right? If suppose, if I was given you the 100 degrees, or if suppose if they have given 100 degrees Celsius, now how much is in the Kelvin scale, this temperature in the Kelvin scale, 100 degrees Celsius, a temperature in the Kelvin scale. How much is the temperature in the Kelvin scale? Good. That is a 373 Kelvin. Right. Good. 373 Kelvin. This is 373 Kelvin. Now I was given 413 Kelvin. Temperature in degrees Celsius. 413 Kelvin I was given. I need temperature in the degrees Celsius. I need. 413 Kelvin I was given. I need the temperature in the degrees Celsius. Kelvin I was given. I need the temperature in the degrees Celsius. Kelvin I was given. I need the temperature in the degrees Celsius. Right. Good. 140. Right. 140 degrees. 140 degrees Celsius. Right. 140 degrees Celsius will be the answer. Right. Now this is about the temperature units. Now next type of the units that we are going to use here, that is the next type of the units that we are going to use, that is hi Yogesh, hi. Now the next type of the unit that we are going to use, that is universal gas constant. Universal, yes Yogesh, I remember you. Universal gas constant R. Now universal gas constant R, that here we are going to use two types of the universal gas constant R value. That is, one is 8.314 joule per Kelvin mole. Okay. Next type of the units that we are going to use for the universal gas constant, that is 0.0821 atm liter per mole and Kelvin. So depending upon the R values, whatever the R values, clear? I can remember, my dear friend, I can remember. Now be concentrate to the class. Now here the R value, whatever the R value we are using, that R value, most of the cases they will give you in the question. Most of the cases. If suppose if they have not given, then depending on the units of pressure and temperature, depending upon the pressure and temperature units, you should use the R value. Depending upon the pressure and temperature units, you have to use the which one? R value. Whether 8.314 or 0.0821. Clear? Done? Now next one. The next we are going to see, that is STP condition. What is the meaning of the STP condition? Standard temperature and pressure. Standard temperature and the pressure. STP. This is short form, we used to say it as a STP. Now the STP condition, first in the old condition they used to use, old condition. Now right? Now Gupta ji, my dear friend, you can if you are in the class 10th, if you want the recap for your what, if you want to listen the advance of the mole concept class, you can listen. Now the old condition of the STP that we are having the 1 atm and 273 Kelvin. Now the new condition we are using here now, new condition, most of the cases the questions we will solve with the old condition only, but the new condition we are having, that is 1 bar or 0 degrees Celsius or 273 Kelvin. 0 degrees Celsius is nothing but 273 Kelvin, right? Now next, here let's suppose we know, right, volume of 1 mole of gas at STP. Now how much volume the 1 mole of gas, how much 1 mole of volume of the gas that having 1 mole will occupy, how much volume he is asking. How much volume it will occupy? 1 mole of gas at STP will occupy how much volume of the gas? How much volume it will be occupied? How much volume it will be occupied? 1 mole of gas at STP, it will occupy how much volume? 1 mole of gas at STP, it will occupy how much volume? Volume of 1 mole of gas at STP, how much? How much volume of 1 mole of gas will occupy? 1 mole of gas at STP will occupy how much volume? Ah, 22.4 liter, right? 22.4 liter, right? Now how the 22.4 liter it will be occupied? How the 22.4 liter it will be occupied? Now I will explain. See, 1 mole of gas at STP, 1 mole of gas at STP, we are having PV is equal to nRT, right? PV is equal to nRT. This is ideal gas equation. Now at STP condition, pressure we will having the 1 atm, right? Pressure we are having the 1 atm. Temperature we are having the 273 Kelvin. 273 Kelvin, right? Now if you send the V to the left hand side, P to the right hand side, nRT by P. P we are having 1 atm, N we are having the 1 mole, R, now the pressure is unit is atm, temperature unit is Kelvin. Then the R value we have to use it as 0.0821, right? Then volume of the gas or 1 mole of the gas at STP, how much volume it is occupying? Moles is 1, R value 0.0821, temperature is 273 and the pressure is 1. If you calculate, it will get the 22.4 liter. 22.4 liter of the volume it will be occupied. Clear? 22.4 liter of the volume will be occupied by the which one? 1 mole of the gas at STP. 1 mole of the gas at STP. Right? This is about the old condition. This is about the old condition. Now, here in the new condition, how much volume it is occupied? Now we'll see. New condition, how much volume it is occupying? Now we'll see. In the new condition, same, V is equal to nRT by P. Now in the new condition, pressure is 1 bar, right? Pressure is 1 bar, right? But the R value we are taking here, the 1 into R value 0.0821 into 273 Kelvin by, but the pressure we are having the 1 bar, but here the unit we are having the atm, liter, but here the pressure if you take the 1 bar, atm and bar unit cannot be cancelled, so you have to convert this 1 bar into the atm. 1 bar is equal to 1 by 1.013 atm. 1 bar is equal to 1 by 1.013 atm. This pressure unit 1 bar, just you substitute this 1 by 1.013 atm. Now this atm will be get cancelled, right? Then this 1.013 which is in the denominator, it will reach to the numerator. V is equal to 0.0821 into 273 into 1.013. If you multiply, now how much you will get, Amma? In the new condition, how much volume it is occupying? Can anyone say me? In the new condition, how much volume it is occupying? In the new condition, how much volume it is occupying? Can anyone? Can anyone say me? How much you got? Calculate it and say me. Approx you will get 22.7 liter. Approx you will get 22.7 liter. Good. Approx you will get the 22.7 liter. Right, good. Next. The next concept that we are going to study, actually in the mole concept, the concepts we are going to study according to the given question data. According to the given question data we are going to study. Right, the next concept that we are going to study, average molar mass. Average molar masses of a gaseous mixture. Average molar masses of the gaseous mixture they have given. Now, average molar masses of the gaseous mixture if they have given, then how to identify? Average molar masses of a gaseous mixture. Average molar masses of the gaseous mixture. Now, here average molar masses of the gaseous mixture, average molar mass formula we are having. See, what is the meaning of the average molar of the gaseous mixture, sir? Why we are going to study this concept? Because see, in our universe we are having the plenty of the gas. One is O2 gas, one is N2 gas, one is SO2 gas, one is CO2 gas, one is SO3 gas. Clear? This many plenty of the gases we are having. So this many plenty of the gases if we are having, how much, in how much proportion, if suppose they are given, they are how much average or how much proportion they are in the universe. These gases, how much proportion, how much by the mole ratio or how much by the gaseous volume ratio they are present. To calculate or to find out that one, average molar masses of the gaseous mixture, that concept we are going to study. So average molar masses, average molar masses of the mixture, average molar masses of the mixture. Average molar masses of the mixture is equal to, the formula we are having, total mass of a mixture, total mass of a mixture by total moles of mixture. Right? Now this is a formula. Or else if you want to, if you want me to simplify the formula, I will simplify. Average molar mass mixture is equal to M1, mass of the mixture, or this is molar mass. This one is a molar mass. Molar mass into number of moles of the gas 1 plus M2, molar mass of the gas 2, molar mass of the gas 2. This is gas 1 Now this is number of moles of the gas 2 by total number of moles, that is N1 plus N2. This is a formula that we are having. So depending upon this formula, now how the question they will ask. Now we'll see. Depending upon the formula, how the question they will ask. Now we are going to see. First of all, calculate the M mixture average molar mass mixture containing SO3 gas and CO2 gas in 2:1 mole ratio. 2:1 mole ratio. Clear? Is asking the M mixture and he has given the two gases. Those two gases are present in the universe 2:1 mole ratio. 2:1 mole ratio. Now in the universe, one SO3 gas it is there, one CO2 gas it is there. These two in the universe, they are present in 2:1 mole ratio. Then how much average molar mass? This average molar mass of this mixture is how much is asking. Can anyone? First one I will explain, second one you try. M mixture is equal to, now M1 gas is SO3. SO3 molecular weight is 32 plus 48. 32 plus 48. 32 plus 48 will be now. Thank you, my dear. I did not remember your name, but thanks for it. Right now, this is a how much? This is 50. This is 10, and this is for 80, right? So SO3 molar mass is 80, and its mole ratio is 2, plus CO2 mole ratio is, this is carbon 12, and here it is a 32. This is 44. 44 into 1 by 3. How much it will get? How much you will get? Can you calculate? 80 into 2 plus 44 by, how much you will get the M mixture? M mixture, how much you will get? M mixture, how much you will get? How much you will get, my dear friends? $174. This is 160 plus 44 by 3. Good, Nitya, good. This is 68. Good, Subhana, good. 68, good. Right? 68. Next one. Next question. Now you see the next question. Next question, if suppose. Next question. Good, Akshara, good. Now calculate the molar composition of gaseous mixture. Molar composition of gaseous mixture. Molar composition of gaseous mixture is nothing but moles is asking. Molar composition of gaseous mixture containing NO and NO2. Whose M mixture is 38. Whose M mixture is 38. My dear friends, this question in the two ways we can solve. How to solve in the two ways? Now will you try? This question, or should I say? He is asking the two gases we are having. These two gases are present in which mole ratio, which mole ratio or how much moles. Let's take this is n1 mole and this is take the n2 mole. Now what is the how much is the n1 mole and how much is the n2 mole? Can anyone say me? Can anyone say me how much is a n1 mole and how much is a n2 mole? Okay, try it from your end. Try it from your end. Okay, try. Try it from your end and say me the answer. Good. Now answer you got it as a 1:1, right? 1:1 you got, right? 1:1 you got. How come? How to calculate? M mixture already they have given. M mixture is equal to M1 N1 plus M2 N2 by N1 plus N2, right? Now M mixture how much we are having? 38. Now take the M mixture as a 38. Molar mass of the N1 is how much? Can anyone? Molar mass of the N1 is how much? Molar mass of the NO, sorry, not N1. Yeah, NO 14 and this is 60. That is 30. Right? And number of moles is asking, right? Take the moles of this N1 is X. Now molar mass of the NO2 will be the 46. Now if the number of moles, if you got the X, from that 100 minus X if you do, you will get the what? Number of moles of the N2 by X plus 100 minus X. X get cancel, and if you solve the question, that is 38 is equal to minus 16x plus 4600 by 100. Now if you cross multiply, it will become 3800 minus 16x plus 4600. Then if you bring it to the left hand side, then it will become how much? 200 plus this is minus 800 and minus 16 by x. Now here minus will get cancelled. Now x will give you the 50%. Now x, if it is 50, that it is representing the n1 mole. N1 mole is 50. Then n2 mole is also 100 minus x, right? That it will give you the 50, right? Now both the cases, n1 is 50, n2 is 50. So mole ratio is 1:1. This is about the calculation. Right? Without calculation, how to do these questions? Without calculation, how to do this question means, see here in the question, M average how much they have given? Where is the question? In the question, M average they have given, sorry, M mixture of the M average they have given 38, right? M mixture if they have given 38, right? Now the only one thing you have to do, now average molar masses of the which one? Average molar masses of this average molar mixture of the NO plus NO2, right? NO plus NO2, that if it is equal to the M mixture, then both the gases NO and the NO2 are in the 1:1 mole ratio. Both are in the 1:1 mole ratio. See now M average mixture of the NO plus NO2. Now this is how much? 30, and this one will be the how much? This is the 32 plus 14. that it will be the 46 by 2. How much it will give? Approx it will give you the 38 only. So the key point you have to remember, note what is the key point you have to remember. Now what is the key point you have to remember? The key point you have to remember is if M average mixture, if M average mixture is equal to, if M average mixture, if it is equal to average molar mass of gaseous, then both the gases will be, present in 1:1 ratio, 1:1 ratio, 1:1 mole ratio, 1:1 mole ratio. This is the one key point you have to remember. 1:1 mole ratio. Right? The next question I will give you. Now you have to say me. Use this trick if it is M average mixture and molar masses of that gaseous mixture, if both have became equal, then both will be in the 1:1. If suppose they are not in the if both the gases are not equal to the M average mixture, then you have to solve the problem. Right? Now question. Calculate the mass percentage, calculate the mole percentage, right? Calculate the mole percentage of each gas, or better you take the mole ratio instead of percentage. Mole ratio, calculate the mole ratio of each gas in a mixture containing SO2 and O2 having M average equal to 50. Say me the answer. M average is equal to 50. M average equal to 50. M average equal to 50. What is the answer you got? .7. Now you see, first we'll see whether they are present in the 1:1 mole ratio or not. SO2 and the O2. SO2 is 32 plus 32, 64. 64 plus 32 by 2. This will give you approx 96 by 2. 96 by 2, this will give you the 48. So molar masses average, we got it as a 48, which is not equal to the M average. If it is not equal to the M average, then we have to solve the which one question, right? Now M average they have given it as 50. 50 is equal to that how much? SO2 gas, right? SO2 means 32 plus 32, 64. 64 into X plus, now 32 into 100 minus X by X plus 100 minus X. X get cancelled, then 50 will be equal to 64X plus 3200 minus 32x by 100. If you take it to the left hand side, it will become 5000. That will become 64. So this is 32 minus x. Then it will become 32x, right, plus 3200, right, 3200. Then if you solve, you will get it as a 9:7. Okay, right. If you solve, you will get the x. You will get the x value. If you solve, you will get the x value. Right. Good. Now, the next concept that we are going to study, percentage composition. Next concept that we are going to study, that is a percentage composition. Now, what is the meaning of the percentage composition? Now, what is the meaning of the percentage composition means? Now, for an unknown or new compound, it is necessary to know the formula, right? And to know the ratio of their constituent in the given compound. See, let's suppose one C6H12O6 they have given, right? This is one compound. This is one compound. In this compound, now how much percentage of the carbon it is there? How much percentage of the hydrogen it is there? How much percentage of the oxygen it is there? Now we have to find. That is known as a percentage composition. Clear? That is a percentage composition. For this molecular formula, in this molecular formula, how much percentage of the carbon is there, how much percentage of the hydrogen, how much percentage of the oxygen is there, that we have to calculate. For that one, we are having a formula that percentage or percentage by mass, percentage of mass of an element. అంటే ఎంత weight తో ఉంది, how much weight or how much mass that carbon it is present. See, let's suppose this molecular weight of this compound is 180, we know. In this 180, how much weight carbon is there? How much weight that carbon is there? Now, how much weight hydrogen it is there? How much weight that oxygen it is there? Or how much percentage in that 180, how much percentage it is there, that we have to calculate. So, percentage will be referred to the 100, right? Right? Now, mass of an element will be equal to mass of that element in the compound. Oh, sorry, better I will write it in the fresh page. Here it is having the some mass percentage. Now, how to calculate the mass percentage of the any compound? Mass percentage of an element, equal to mass of that element in that compound, by molar mass of the compound into 100. Clear? Now, in this manner, we have to find the mass percentage of the element in that compound. Let's suppose we'll go with the simple example for you, that is H2. H2O molecular weight is 18, right? In this H2O, how much mass percentage of oxygen we are having, that we have to calculate. So, mass percentage of the oxygen, now how many oxygens we are having? Only one, right? Now, 1 into 16 by 18 into 100. That if you do, you will get the mass percentage of the oxygen, right? Now, mass percentage of the hydrogen, how to calculate? Now, how many hydrogens we are having? 2, right? 2 into its molecular weight. Its atomic weight will be 1. Its atomic weight will be 1 and its molar mass will be 18 into 100. clear, that it will give you. Or else you can justify or you can modify this formula in another manner also. If you are getting confusion, you can modify this formula in the another manner also. How to modify this formula? This mass percentage will be equal to number of atoms that element, number of atoms that element into its atomic mass, by molar mass of the compound, into 100. This is also the same formula. Now how much is the mass percentage of oxygen, how much is the mass percentage of hydrogen? Can anyone say me? How much is the mass percentage of oxygen, how much is the mass percentage of hydrogen? Can anyone say me how much is the mass percentage of oxygen and how much is the mass percentage of hydrogen? How much is the mass percentage of oxygen and how much is the mass percentage of hydrogen? Good, Subhana, good, Akshara, good. Now this is 88.8 and remaining will be the 11.1. Good, Joshita, good. Now I will write a one question. Right, good. I will write a one question. In which of the following has same percentage composition of carbon? He is asking in which of the following having the same percentage composition of the carbon. Okay, first one. Now second one, this is second one, and the third one, and fourth one, this is the fourth one. Now say me the answer. This is 1, this is 2, this is 3, and this is 4. Now here the 4 compounds they have given. Among the 4 compounds, in which of the following, or how many of them having the same carbon percentages in that compound? Say me. Now say me the answer. Now say me the answer. Are you trying? My dear friends, are you trying? In which of the following has the same percentage composition of carbon? Okay, try. 'Be fast'. One and three, sir. Only 1 and 3 you got? Only in the 1 and 3 you got? Only in the 1 and 3 you got? See. Now the first one is a percentage of carbon in a, this is formaldehyde. Now this is a formaldehyde. Now the percentage of carbon is 1 into 12 by 30 into 100. 4 also. Fourth one also we are having same. So this will give you the 40%. Right? Next, percentage of carbon in the, which one? Acetone. Now percentage of carbon in the acetone. Here how many carbons we are having? 3. 3 into 12 by 58 into 100. If you do, you will get approx 62.07 percentage. Right? Next one. Percentage of carbon in acetic acid. Percentage of carbon in the acetic acid. This is fourth. Here we are having 2 carbons, right? 2 into 12 by how much? 60 into 100. If you do, you will get the 40% only. Right? Next one we are having the percentage of carbon in glucose. C6H12O6. How many carbons we are having? 6. 6 into 12 by 60 into 100. That it will give you the 40% only. Right? Right? In the formaldehyde, in the acetic acid, in the glucose. So the answer will be, so 1, 3 and 4. In the 1, 3 and 4. 1, 3 and 4. Okay, good. In the 1, 3 and 4 we are having the same percentage of the composition of the, right. Next one, the next concept that we are going to study, that is the next concept what we are going to study, that is a vapor density. Vapor density concept is also very important. My dear friends, this is very important concept, because the questions they may stress directly or indirectly from the vapor density. Directly or indirectly they can stress the questions. So vapor density formula, how the vapor density questions and the formula it has came. Now we'll see. Vapor density is equal to, now this they have related density of a gas, relative to density of H2 at same temperature and pressure. At the same temperature and the pressure, this it has been related. It has been related. So vapor density is equal to density of some gas, by density of H2, at a same temperature and the pressure. Same temperature and the pressure. Now at the same temperature and the pressure, now ideal gas equation that we are having, PV is equal to nRT. PV is equal to nRT. Now in this PV is equal to nRT, now if we have modified this formula, now number of moles formula, mass by molecular weight into R into T. If you send the which one, molecular weight R, if you send the V to the left hand side, if you send the V to the left hand side, P is equal to mass by volume into RT by molecular weight. Now density formula, density is equal to mass by volume, we know, right? Now mass by volume, this P is equal to density into R into T by molecular weight. Now if you send this molecular weight and the R to the left hand side, then it will become density is equal to P into molecular weight by RT, molecular weight by RT. Now at the same temperature and same pressure and universal gas constant value, these three values are constant. Same temperature and pressure, right? You can see same temperature and pressure. Same temperature and pressure means pressure is constant, temperature is constant, R is constant. Then only what it is changing, molecular weight is changing. Molecular weight of O2 is different, molecular weight of SO2 is different. But conditions for the SO2 gas and the conditions for the O2 gas, pressure is 1 atm, SO2 gas also 1 atm. R, T temperature, O2 for same, SO2 is also same. So then density is equal to pressure into molecular weight by R into T. This formula, same this density formula we are going to substitute in this vapor density formula. Same we are going to substitute in this vapor density formula. Vapor density is equal to pressure into molecular weight of gas by R into T by P into molecular weight of H2 by R into T. Here R into T, pressure will be get cancelled because all are same. Then vapor density will be equal to then this vapor density will be equal to molecular weight of gas by molecular weight of H2. Molecular weight of H2 is 2, right? Vapor density is equal to molecular weight of gas by 2. This is a vapor density formula. This you have to remember. Right? Now depending upon this formula, we are having a one question. Now we'll solve the one question based on this formula. Now what is the formula? One X compound having vapor density is equal to 90. What is its molecular weight? What is its molecular weight? Can anyone say me? Can anyone say me the answer? Right, good. Then vapor density is equal to molecular weight of gas by 2. Vapor density is 90 into 2 is equal to molecular weight of gas. That it will be the 180. Right? Next. Now the next concept that we are going to study, that is molecular formula and the empirical formula. Molecular formula and the empirical formula that we are going to study. Right? What is the meaning of the molecular formula and what is the meaning of the empirical formula? Next concept that we are going to study, that is a molecular formula. Now, what is the meaning of the molecular formula? Molecular formula means the formula which gives exact number of elements, that are present in one molecule, of compound. One molecule of compound. Now, one molecule of the compound. Now, that exact number of elements that are present. Example, molecular formula of glucose, if I write that it is a C6H12O6. This is a molecular formula of that compound. Now, next one, the next concept that we are having, that is a empirical formula. Empirical formula. What is the meaning of the empirical formula? Now, the next formula we are having, it is a empirical formula. Now, what is the meaning of the empirical formula? Means formula, now citing the constituent atoms in their simplest ratio. If the same molecular formula, now the same molecular formula that we are making into the simplest ratio, we call it as a which one? That is a empirical formula. Now you see, now how to make the simplest whole ratio? If I was taking the one molecular formula of example of the C6H12O6. Now, if I want to make it into the empirical formula, simplest formula, now which cannot be further divided, that how to make the simplest formula? If I divide it by the 6 for this one, then it will comes into the simplest whole ratio. But that simplest whole ratio, it should be there, complete simplest, it should not be in the fraction. Then if I divide it by the 6, then it will become CH2O. Now this is a simplest formula or empirical formula, we can say. Still further we cannot further be divided, because if you divide it by the 2, again it will become 1 by 2, here it will become 1 and it will become 1 by 2. It should not be in the fraction, it should be in the complete number. So here empirical value, here the empirical value n will be the 6. This empirical value n also will play the very, very crucial role. This n should be, alright, here note n should be integer, n should be the integer, and it should not be equal to 0, and should not be equal to 0, right? Now my dear friends, I will give you the some compounds. You have to say me its empirical formula and its molecular formula, and what is its n value, you have to say me. What is its n value, you have to say me, right? Here it is a molecular formula. Now this is a empirical formula, and what is its n value? Example, C6H12O6. What is the empirical formula and what is the n value? And CH3COOH. What is the empirical formula and what is the n value? Now say me the answer. Can anyone say me the answer? Can anyone say me the answer? CH2O CH2O, good, CH2O and N value is 6. Okay, next, for the acetic acid, for the acetic acid, no, see this acetic acid also we can write it in this manner, right? C2H4O2, then its empirical formula will be CH2O and its empirical value is 2. Here this one will be the CH2O and its empirical value is 6. Its empirical value is 6, not 3. You have to be very careful with this one. You have to be very careful with this one, right? Now for this one, now here you have to be remember one point. What is the point to be remember? What is the point to be remember? This is the one point you have to remember. Now note, if two compounds empirical formula may be same, two compounds empirical formula may be same, but molecular formula will not be same, okay? This is the one key point you have to remember. For any compound, for any two compounds, here you can see this is the one glucose, one is the acetic acid. Glucose and the acetic acid empirical formula is same, but molecular formulas are different. This is C6H12O6, this is CH3COOH. Means for the any compound empirical formulas may be same, but molecular formula should not be same. Now how to find the N value? To find the N value, this is empirical formula value. This is empirical value. Now to find the empirical value, N is equal to molecular formula by empirical formula. See, after getting the empirical formula, now if you divide it by the empirical formula or weight, or empirical formula or weight, then by that you will get the N value. Suppose sometimes you will get the empirical formula and you will get the N value, then if you want to find the molecular formula will be equal to N into empirical formula. In this manner also you can find the molecular formula. By this formula also you can find the which one? Molecular formula, right? Here now based on this one we'll do a one question, so that whatever the concept you are having, that it will be clear for you. But to determine the empirical formula, here you should have or you should follow some rules to find empirical formula from the question, from the given data of the questions. From the question, if you want to find the empirical formula, these are the some key steps, or these are the some key points you have to follow. What is the key point? The first key point, that is first of all, find percentage by weight of each element. Percentage by weight of each element present in compound. Percentage by weight in each compound. Done. Second, the percentage by weight of each element each element is divided by its atomic weight, divided by its atomic weight, to give the ratio of elements. What? To give ratio of elements, to give the ratio of elements present in the compound, right? Now that atomic ratio of each element is divided by the minimum value. This is a very key point, third point, right? Atomic ratio of each element, atomic ratio of each element is divided by the minimum value, divided by the minimum value of atomic ratio, minimum value of atomic ratio. So we get simple ratio of atoms. Sir, what are the points you have written, sir? We did not understand. Now with the help of question you will get understand. Now listen, what is the question? A organic compound contains, right, 49.3% carbon and 6.84% hydrogen, and its vapor density is 73. Its vapor density is 73. Calculate molecular formula of compound. Calculate molecular formula of compound. Now say me the answer. Calculate molecular formula of the compound. Now very key point you have to remember. Note. What is a note? First of all, percentage refers to the 100. In the question, percentage of carbon is 49.3, percentage of the hydrogen is 6.84, right? This two if you add, you will get it as a how much percentage? This is 56.110%. 56.110%. To refer to the 100%, when we are in the question, the percentages if we add, we got it as a 56%. Then to make it to the 100, how much we have to add? That percentage will be the how much? This was how much? 56, right? Then we have to add the 43.90. 43.90 if you add, this weight will be the percentage of oxygen. They will not give you in the question, my dear friends. You have to be very careful. This percentage of oxygen by the weight they will never and ever will provide in the question. If suppose only the carbon and the hydrogen weights they have given, then it is not related to the 100%. When you added, when it is not related to the 100%, then the remaining, then the which one? Then the remaining percentage will be refers to the oxygen. Now we will see. Now first one, the carbon, hydrogen and the oxygen, right? Now the carbon percentage we are having 49/3, right? Hydrogen percentage will be the 6.84. Now the remaining, the percentage of the which one? The remaining percentage of the oxygen, it is 43.90. This is percentages by weight, right? Then if you divide it by their atomic weights, if you divide it by its atomic weights, you will get the mole ratio, right? Simplest mole ratio you will get. after getting the simplest mole ratio, how to identify? Can anyone say me? Can anyone do this question? Can anyone do this question? And say me what is the formula for this one? Now if you divide it by its atomic weight, 49 by 3, it will be 12, and it will be the 6.84 by 1, and this is 43.90 by 16. Can anyone say me the answer for this one? Can anyone say me the answer for this one? It will give you approx 4.110. Now this one will give you the 6.84. Now this one will give you how much? 43.90 by 16. It will give you the 2.74. 2.74. Actually what they have given? Organic compound content 43% of carbon and 63.8% of weight. They have not given by the weights. Actually they have not given by the weights, my dear friends. Then we should not do in this manner. Wait, in the question they have not given by the weights. They have not given by the weights. Just they have given only the organic compound content 49.3% of carbon and 66.84% of hydrogen, and its vapor density is 73. Now can anyone say me? Now can anyone say me the answer? My dear friends, someone is requesting me to talk in the Kannada. ಏನಪ್ಪ ನಿಮಗೆ ಕನ್ನಡದಲ್ಲಿ ನಾನು ಏನು ಮಾತಾಡಬೇಕು? ಮೈ ಡಿಯರ್ ಫ್ರೆಂಡ್, ನಿಮಗೆ ಏನು ಬೇಕು ಕನ್ನಡದಲ್ಲಿ? ನಾನು ಏನು ಮಾತಾಡಲಿ? ಥ್ಯಾಂಕ್ ಯು whatever the compliment you have given, my dear friend. Now right, see in the given question the vapor density they have given it as a 73. Clear? Molecular weight, vapor density of the 73, then the molecular weight of that gas will become 2 into 73, that it will be. ಸಾಕಪ್ಪ ನಿಮಗೆ ಕನ್ನಡದಲ್ಲಿ ಮಾತಾಡಿ ಅಂತ ಹೇಳಿದ್ರಲ್ವಾ? ಸಾಕಾ ಕನ್ನಡದಲ್ಲಿ ಮಾತಾಡಿದ್ದೀನಿ ನಾನು? Now the percentage composition of the carbon, now that we can calculate that it is on the basis of which one? In the 146% of the carbon. Acha hauda, good. Sari appa, KCT banta nimge? KCT next what you got? KCT or JEE or anything? This much weight you will get. This much weight you will get in the 146 molecular weight. Okay, thank you my dear friend. Good. Okay, 146 into 6.884 by 100, that it will give you somewhat 9.96. Acha, okay, good. BSc nursing. Ellie, where you are going? Where you are joining? Oxygen in the 146. Howda? Okay. Now, Eliamma, where you got? I mean, college. Yavud college banto? That it will give you approx 64.86. Howda? Okay. Good. Sorry. Now you can see Nana. Now by the given compound, the weights you got. Oxygen, hydrogen and the no. Enilla. Angenilla. Right. My dear friends who are in the live, just try to say me the answer. Now the carbon, hydrogen and the oxygen weights we got. Actually by weight they have not mentioned, only percentages they have given. In the vapor density they have given. Vapor density say ನಾನು ಹೈದರಾಬಾದ್ ಅಮ್ಮ. ಆ್ಯಕ್ಚುಲಿ ಮುಂಚೆ ನಾನು ಮೈಸೂರದಲ್ಲಿ ಇದ್ದೀನಿ. ಇದಿರಲ್ವಾ, ಈಗ ನಾನು ಹೈದ್ರಾಬಾದ್ ಶಿಫ್ಟ್ ಆಗಿದ್ದೀನಿ. ರೈಟ್, ನಾವು carbon weight we got it as how much? 71,978 by 12 carbon weight. Next 71,978 of the hydrogen. Here how much you got? Here approx you will get it as approx you will get 9.986 by 1. Then this one it will give you the 64.86 by 16. Approx you will get it as, here approx you will get it as 6 moles, approx you will get it as 10 moles. Okay, next you are having the 4 moles. Here it is having the 4 moles. Clear? Carbon it is having the 6 moles, hydrogen it is having the 10 moles, and oxygen it is having the, clear, and oxygen it is having the 4 moles, right? Then simplest to whole ratio, what is the simplest form here? Simplest it is the 4, right? Already we got the, which one? Weight is asking, and it is asking the molecular formula, right? Molecular formula we will get it as a C6 what? H10O4. This is a molecular formula, directly is asking. Weights I was found at, and weights from that, clear, that you got it as a molecular formula. My dear friend silent killer, ನಾನು ಒಂದು ಕಾಲೇಜಲ್ಲಿ ಪಾಠ ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ಹಂಗೇನಿಲ್ಲ, ನಾನು ಅದು ಆಕಾಶ್ ಮತ್ತು PW ಎಲ್ಲ ಬಿಟ್ಟಿದ್ದೀನಲ್ವಾ, ಈಗ ನಮ್ಮ ಕಾಲೇಜ್ ಸ್ಟೂಡೆಂಟ್ಸ್ಗೋಸ್ಕರ ಈಗ ಇದು ಸ್ಟಾರ್ಟ್ ಮಾಡಿದ್ದೀನಿ. ಈಗ ನಿಮಗೆ ಏನಾದರೂ ಜೂನಿಯರ್ಸ್ ಇದೆಯಂದರೆ ಅವ್ರಿಗೆ ಶೇರ್ ಮಾಡಿ, ಓಕೆ, ಅವ್ರಿಗೂ ಹೇಳಿ ನಮ್ಮ ಸಾರ್ ಇದ್ದಾರೆ, ಅವ್ರು ಕೆಮಿಸ್ಟ್ರಿ ಚೆನ್ನಾಗೇ ಹೇಳ್ಕೊಡ್ತೀರಂತ, ಓಕೆ, ಯು ಕ್ಯಾನ್ ಸಜೆಸ್ಟ್ ದೆಮ್, ರೈಟ್? ಈಗ ನಾನು ಒಂದು ಕಾಲೇಜಲ್ಲಿ ವರ್ಕ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ಅವ್ರಿಗೋಸ್ಕರನೇ ಇದು ಕಾಲೇಜ್ ಯೂಟ್ಯೂಬ್ ನಾನು ಸ್ಟಾರ್ಟ್ ಮಾಡಿದ್ದೀನಿ. ಓಕೆ ಮೈ ಡಿಯರ್ ಫ್ರೆಂಡ್ಸ್, now this is a one question. Now one question I will give you, the one who are in the live, my dear friends, actually this is a complicated question, I think so you are thinking. Now one simple question I will give you. Now based on that simple question you can try it by your end. Right, ನಿಮ್ಮ ಹೆಸರೇನಪ್ಪ? ಅಮ್ಮ, ಈಗ ಪರ್ಸ್ನಲ್ ಇರಬಾರದು, ಇಲ್ಲಿ ಪರ್ಸ್ನಲ್ ಏನೂ ಹೇಳ್ಬಾರದು, ರೈಟ್? ಮೈ ಡಿಯರ್ ಫ್ರೆಂಡ್, ಮೇ ಐ ನೋ ಯುವರ್ ನೇಮ್? ನಾವು an organic compound found to contain 75% of carbon and 25% of hydrogen by weight. What is empirical formula and molecular formula of the compound? My dear friends who are in the live, can anyone say me? My dear friend, okay, you just asked me to talk in Kannada. ಈಗ ನೀವು ಕೇಳಿದಿರಲ್ವಾ ಕನ್ನಡ ಸರಿ ಒಂದು ಸಾರಿ ಕನ್ನಡದಲ್ಲಿ ಮಾತಾಡಿ ಅಂತ, ನಾನು ಮಾತಾಡಿದ್ದೀನಿ. ಈಗ ನಿಮಗೆ ಏನಾದರೂ ಇನ್ನೂ ಕನ್ಸರ್ನ್ಸ್ ಇದೆಯಂದರೆ ಆಮೇಲೆ ಲೈವ್ ಮುಗಿದು ಆದಮೇಲೆ ನಾನು ನಿಮ್ಮ ಜೊತೆ ಮಾತಾಡ್ತೀನಿ. Now my dear friends who are is in the live, once try to say me the answer. Once you are in the live, just say me hi. The one who are in the live, once you say me hi and try to do this question. My dear friends who are is in the live, just say me hi and try to do this question and say me the answer. Okay, Subhana, good, good, good. Now, can anyone say me the answer? Can anyone say me the answer for this one? Can anyone say me the answer for this one? My dear friend, be fast. Just is asking the empirical formula and the molecular formula. What is the answer you got? What is the answer you got, Amma? You can see, right? Carbon percentage by weight they have given 75. Hydrogen percentage by weight they have given 25. If you divide it by its atomic weight 75 by 12 and it will give you the 25 by 1. Right? 75 by 12 how much you will get? 75 by 12 you will get approx 6.25. This one will give you the 25. Now this is the simplest whole number, right? Simplest whole number divided by the 6.25 and this you divided by the 6.25, right? Now 25 by 6.25 it will give you approx 4. Now this one will give you 1. So the what empirical formula you got it as C1H4. C1H4. Then he is asking the molecular formula, right? To find the molecular formula, N value will be equal to the molecular formula, molecular weight they have not given. Empirical formula we got it as a C4, C and H4. But molecular weight did they given in the question? Molecular weight if they have not given in the question, molecular weight if they have not given in the question, then we cannot find or any organic compound question or any molecular formula or organic compound weight if they have not given, we cannot find the which one molecular formula of that compound. Only the empirical formula we can find. Okay, my dear friends, I hope this is clear for you. And almost it is 8:54. I was not seeing the time only. Okay, now my dear friends, I was going to end the live here. If you are having any concern, you can ask me. And tomorrow we are going to see the limiting reagent and next consecutive reactions or any other very important reaction that we are having, that we are going to see. Anyone are having any concerns? Anyone are having any concerns? Anyone, if they are having any concerns, they can ask me. If not, I will end the live. If not, I will end the live. Should I end the live? My dear friends, beginners chemistry is the Insta ID. Okay, good. Beginners chemistry is the Insta ID. Beginners chemistry ಅಂತ ಟೈಪ್ ಮಾಡಿ ನಿಮಗೆ ಬರುತ್ತೆ. ರೈಟ್. ಸೈಲೆಂಟ್ ಕಿಲ್ಲರ್ ನಿಮ್ಮ ಹೆಸರೇನಪ್ಪ? ನಿಮ್ಗೆ ಹೆಸರೇನು? ನಿಮ್ಮ ಹೆಸರೇನಪ್ಪ? ಇಲ್ಲ ಇಲ್ಲ ಇಲ್ಲ, ಅದರಲ್ಲಿ ಏನಿಲ್ಲ. We should not disclose or we should not say the salaries or anything personal in the online platform. I hope you will understand. Beginners chemistry Insta ID. This is the Insta ID. I hope you can understand. Oh, your name is Akash only. Acha acha. Fine, fine. My dear friend, I was worked in the Akash also. So I thought you are asking the salary when I was worked in Akash. Sari appa. Okay. Fine. Still anyone in the live? Okay. Bye bye. See you tomorrow.